Okay, today we are going to start Unit 5.1, Mid-Segment Theorem. Now, the other day we did the graphic organizer where we talked about the mid-segment of the triangle, and we said that the mid-segment of a triangle is a segment that joins the midpoint of two sides of a triangle. Okay? Every triangle is going to have three mid-segments. So looking at this triangle here, we have triangle AHQ. W, X, and Y are the midpoints, which means that AW will be congruent to WH. Because W is our midpoint. So if X is the midpoint of HQ, I can say that HX is congruent to XQ. Again, remember when we label something with congruent marks, they have to be the same. I needed to have two congruent marks here because I already said that these two segments were congruent to each other. So the same thing down here. I have AQ and the midpoint is Y. So AY is congruent to YQ. Now these midpoints all connect each other. And they form their own little triangle inside the bigger triangle. Okay? So these midsegments can be labeled as WX Remember when we label a segment, we put the line over top. My other one is XY. And my final segment is WY. Okay? All right, well, let's dive deeper into this theorem and find out what does this mean and how do we prove it. All right, so the mid-segment theorem. Mid-segment of a triangle is parallel to the third side of the triangle, and its length is equal to half the length of the third side. Well, what does all that mean? Well, let's look over here at our sample. There will be times when you're given information and then you have to label it. So we need to label MQ is the midsegment. Again, the midsegment is a segment that joins the midpoints of the two sides. So we're going to put M here and Q here. Those are your midpoints. So if M is the midpoint of AB, we can say that AM is congruent to MB. And if Q is the midpoint of BC, that means that CQ is congruent to BQ. Now, if I look back at my theorem, it says a midsegment of a triangle is parallel to the third side of a triangle. Well, here's 1 and 2 where the midsegment went through. So this is my midsegment. It's telling me that this is parallel, MQ is parallel to AC. Okay, so I would label that as MQ is parallel to AC. And I know that because that is what my theorem tells me. My theorem also tells me that its length, that MQ, this length here, is equal to half the length of the third side. Well, the third side is AC, so it's half of AC. Well, you may be thinking, well, how does that work? So what if I say that this here, MQ, is 6 centimeters? Well, if this is half of this, what is the total of AC? The total of AC would be 12 centimeters. Because if I take half, which is 6, and if I have another half, which is 6, 6 plus 6 is 12. So AC is 12 centimeters. All right, let's turn it over and try another one. Let's look at another example. If you have highlighters, it will be helpful to have those highlighters out. And I do notice on here there's a typo. So numbers 1, 2, and 3, this should actually say parallel. So for some reason, the square connected to itself. So those should be parallel. All right. Let's take a look at this. So WX. It's asking for WX. So I'm going to highlight that in purple. It's asking what segment is WX parallel to? Well, the midsegment we know is parallel to the third side. The third side is AQ. So WX is parallel to AQ. And you can just label it like that. I'm going to put 2 in there just to make this a little bit easier to see. All right, so WX is parallel to AQ. All right, now it is telling me that WY is parallel to something. So WY is parallel to something. Sometimes you need to turn your triangle to see it. So this is my triangle. Now WY has cut my triangle at the midsegment, which then will make HQ parallel to WY. So I'll label this with just one marking. Okay, everybody see that? When you turn the triangle, sometimes it's easier to see those parallel lines. So WY, again, is parallel to HQ. We have one more set of parallel lines. It's telling me that XY, which I'll highlight here in green, is also parallel to something. Again, it might be easier to turn your triangle so you see your triangle. You'll see the triangle this way. XY is my midsegment, and it's bisecting those two sides, which means that it is parallel to HA. So I'm going to label this with 3 markings to indicate that it's parallel. Okay, so XY is parallel to HA. The reason I did this in color is so that you can see it a little more clear. All right, so that's a lot of information so far that we have within that triangle. Now, let's see what else we can find. It's telling me that AW, this segment right here, AW, is congruent to what? AW is congruent to what? It's congruent to WH. Don't forget, when we are doing segments, we need to make sure that there is a line over your 2 points. All right, let's look at AY. AY is congruent to what? Find the similar markings. AY is congruent to YQ. Okay. What about XQ? XQ is congruent to what? XH. Again, look at the markings. Okay. All right, now it's going to give me some information down here. And it's telling me that if WX, which is this line right here, is 18, then what is AQ? So if this here is 18, they want to know what AQ is. Well, again, this is the midsegment. It is parallel to the third side of the triangle. We also know that its length is half of this. So if this is 18 and I add another 18, it will give me AQ. So AQ is 36. So from here to here is 36. So now it's telling me, I'm going to turn my triangle. It's telling me that HQ is 25. Well, this line here, HQ, is parallel to WY up here. And this is the midsegment. Well, this is 25. This is half of that. So half of 25 is 12.5. So WY is 12.5. Okay, see how I'm labeling that? All right, let's look at XY. XY, which is in green, I'm going to turn my triangle this way, is 11. So if this is 11, which is half of this, so if I take 11 and then add another 11, I'm going to get 22 for AH. So this here is 22. Notice how the pink, if I double that, it'll give me the other pink line. My purple line, if I double that, gives me that purple line. My green line doubled gives me that green line. All right. Now, let's go back up to number 4. And let's see what else we can determine. Because there is another segment that is congruent with these two already. So I have AW, which is here, is congruent to WH. Now, what is half of 22? If this whole thing is 22, then each of these are 11. What else do we know is 11? XY. So XY is also congruent to AW. Now I see AY and YQ are congruent. Well, this total thing is 36. I know that half of 36 is 18, so AY is 18. YQ is 18. What else in this diagram is 18? Right. WX is also congruent because it also is 18. So AY is congruent to YQ, which is congruent to WX. All right, see if you can figure out number 6 on your own. We have xq congruent to xh. We know the total of HQ, which we have labeled 25. So figure out QX and XH. And you know that half of 25 is 12.5. So if each of these are 12.5, what other segment is 12.5? WY. So WY is also congruent to HX and XQ. All right, let's tackle this one at the bottom. So let's draw a triangle. All right. So it says if WX is 3x plus 8 and AQ is 2x plus 24, what is WX? Well, let's label this. So WX is my midsegment. WX is 3x plus 8. AQ is 2x plus 24. Well, my midsegment theorem tells me that if WX equals 1/2 AQ, so now I just have to plug in what I know. Well, WX is 3x plus 8. My 1/2 I can't change, but my AQ is 2x plus 24. There's nothing to do here on the left side of my equation, so that stays the same. However, on this side, on the right side, I have a fraction. And my fraction tells me I need to take 1/2 of 2x plus 24. When I have a fraction, I divide by the denominator and I multiply by the numerator. So if I divide 2x by 2, I simply get x. And if I divide 24 by 2, I get 12. Now I need to combine like terms. I'm going to subtract x and get 2x plus 8 equals 12. Then I need to subtract 8 and I get 2x equals 4. Divide by 2 and x equals 2. Now I'm not done because I need to substitute the 2 in for x so I can determine the length. So I have 3 times 2 plus 8. Well, 3 times 2 is 6. plus 8 is 14. Again, I'm going to substitute the 2 in for x. 2 times 2 plus 24. 2 times 2 is 4, plus 24 is 28. So looking at this, did I prove that this is half of AQ? Yes, I did. Okay, we are now going to work on worksheet unit 5.1a.